and I am live. That is cool. I haven't streamed for 3 days. I had my college exams and stuff going on at home, but right now I'm back. And also, the other days when I didn't have my college exam, there was CF Code Forces contest. So I guess that could be a valid reason for not streaming. But yeah, anyways, in today is 8th of July. Tuesday 2025, and I will be reviewing the two contests that I gave, that is 1035 and 1036 contest number on Code Forces. And let's just begin. And yep, YouTube also knows that I'm live. That is pretty cool. And yeah, this guy is Ericto. He's pretty nice. He teaches stuff. And Code Forces. Yep, here we go. And my rating did increase. Now I am rated 1093. I have given 4 competitions. That is cool. And not competitions, contests. And final standings for this one, 1035. Let's see. I was able to do 3 questions in this. And yep, friends standings. That is just me alone. And shit, I was able to do 2 questions, and the third one I was unable to do, but I did it afterwards, after the competition, the contest, after the contest. And let me go to the folder where I did solve them. Yeah, first one is this, and or XOR CPP, and this is the solution. So in this first question, we have, yeah, what you have, you are given two non-negative integers a and b. You can apply two types of operations on a and on a any number of times in any order. A, just add 1 to a, or add or take XOR of a with 1 and put it equal to a. And I have to do these operations some number of times, and I have to make a equal to b, and this adding 1 has a cost of x, and adding y has a cost of y. Adding taking XOR with 1 has a cost of y, and in some cases it might not be possible to make a equal to b. So here I have a, here I have b. This is x, cost of adding 1, and this is y, cost of taking a XOR. And what does this mean? This is like pretty simple, just adding 1. And in this case, XOR with 1 would mean that a would become a plus 1 if a is even, that is at the last place, at the least significant place. If there is a 0 in a, then taking XOR with 1 will make it equal to 1, and a would be increased by 1. And if there is a 1 at the least significant bit, LSB, then a would be reduced by 1, and that is cool. So our goal would be to, well, first of all, if a could be greater than b or equal to b or less than b, and if a is less than b or equal to b, then there would be one way to solve this. And if a is greater than b, then it would only be solvable when a equals b plus 1 and a is odd, because we can, like, this operation increases a, so we won't be able to decrease a by this, and this operation only decreases a one time when a is odd. So if a equals, if a is greater than b, then the only case when a can become equal to b would be when b is even and a is odd and a minus b is 1. So that is what I'm checking in my solution also right here. If a minus b is greater than equal to 1, then I'm checking if a minus b equals a and a is odd. And if that is the case, then type in y. That would be the cost of doing the XOR operation once. And if not, then -1. It would not be possible. And I think this I can remove taking an and with one. Taking an and with one would only return 1 if a is 1. If a is odd, and not 1 if a is not odd. Right. And I think this one also could be optimized. I do not have to compare. If a minus b greater than equal to 1, yeah, that would be necessary because negative numbers would also count. Yep. And if that is not the case, if a is either lower or if a is either lower or equal to b, then this is what I'm doing. I find the diff, so I have to increase a by diff, and cost initially is 0. Now, if y is lower than x, that is the cost of this XOR is lower than cost of adding one, then we would like to add as many XORs as we can while covering up the difference. And for that there is this. But if not, if x is either equal to or less than y, then we can just add up the difference, and the cost would become difference multiply by x and then just return the cost. But if not, then we want to add in as many XOR operations as we can, and for that this is what we are going to do. Cost equals difference divided by 2 multiply by x plus y. And what does that mean? That means that there is a difference, like, wait a minute, yo, strong 313, it is 128. And if this is what you are referring to, yeah. And pop-up chat, that's cool. And yep, there is a difference that you want to cover, and let's say this is a number that you want to cover, and this is your diff, right? Cool, amazing writing. This is your diff, and to cover this there could be a couple of cases. Your a is here and your b is here, and you want to increase a this many times to get up to b, right? So among these cases, this is 1 2 3 4 5 6 7 8. So this is cool, this is 8, right? So it does not matter a is even or odd, right? Because if a is even, then to increase a by 1, we can do our XOR operation, because the last bit would be 0, and 0 XOR 1 would result in 1. So a would be increased by 1 by doing XOR here, and when it is 1 we cannot do XOR, so we would have to do like addition, normal addition, which costs x, and then the last bit would again become equal to 0. Then we can do our XOR and then add, then XOR, and this cycle just repeats. XOR, add. So if the difference is even, then we can just divide the whole thing by 2, and half of the operations would be XOR and half of the operations would be adding one. So that is what I am doing initially. Divide diff by 2 and multiply that by x plus y, and that would just result in the sum of these cost. And if there is a difference, if diff is odd, then we have to see there will be an extra operation, and we have to figure out that extra operation is XOR or addition. right? And that would depend on the value of b, it seems. That would depend on the value of b, and how is that? Let's say, right, the difference is odd. So if b is odd, then a would be even, and if b is even, then a would be odd. So let's say even is represented by like a lower dash and odd by a higher dash. So our example number would be something like this. We have a here at even and b here at odd, and the difference is odd. 1, 2, 3, 4, and 5. We have to increase a by 5. So first we can do XOR and then addition, then XOR to get here, then addition like we normally do. So these four operations are pretty nice, and we have already added them in this diff divided by 2 into it. And to see this, now after doing this, we have to see if b is odd, then we can perform a XOR and increase a by 1 to get up to b. And so if b is odd, then we add y, and if it is even, then we add x, and yeah, that is what we return, and cool. So I did that, and I guess in first try. Yep, first try. Acha. And then the next problem, we'll see. And in this standings in this competition, my rating increased by, let me see, this was my third competition. Yeah, my rating increased by 244. Yep, 244. Let me go back to the competition. So that was problem number 1. Hmm. And this line segment, problem number 2. What was this? Yeah, okay, okay. Yes, yes, now I remember. This one I could have done faster, and how much time did it take me? Yeah, sure. Yeah. Third one I was not able to do. And first one I got in the first try, second one after one wrong submission, and the third one I was not able to do. Yeah. Mm, Like during the competition, I was not able to do. I had to read the not tutorial, the editorial afterwards, and then I was able to do it. It took me 9 minutes to do the first one, and 30, 21 minutes to do the second one. 21 minutes. 21 minutes is a very long time to do this question. This one, line segment. So in this question, we are given 2 points on an on a Euclidean plane, which just means like bare a plane with no curves, right? Unlike the surface of the Earth. So you start at starting point 1, and you will perform n operations, and in every operation you must choose any point such that the Euclidean distance between your current position and the point is exactly ai. So we have an array of distances, and yeah, we have a starting point in this case, which is this, and an end point, and then we have a certain amount of operations that we could perform. So from the starting point, I can move three Euclidean distances in any direction that I want, and then again 3 Euclidean distances in any direction that I want, and I have to figure out, can I reach this point, the end point, after performing these operations? And if yes, then yes, and if no, then no. So for this, my thought process, yeah, I was thinking bad when I started this, but over time it became better. yeah, it is something like this. We are given a starting point S and an ending point E, and we have a list of operations, a set of operations which we could do, a set of movements that we could take, and at the end of those, we have to decide can we reach the ETH point. And yeah, we are given distances A0, A1, A2, A3, and yes, I am writing with my mouse, which is like full pirate software thingy. And yes, so my initial thought was that I could add all of these distances up, and the maximum length that I can reach would be some point, which would be A0 plus A1 plus A2 plus A3 plus A4, and the maximum distance, if the distance between my starting point and my end point is lower than this maximum distance, then I should be able to reach this point, right? But that is not the right thing. It's that would be the maximum horizon that I could achieve. Let's say this is my starting point, and then I can perform some set of operations, right? Yes, I could perform some set of operations, and let's say I am going by performing all of those operations in a single direction. This is the maximum distance that I can go to. So if the endpoint is outside this, then no, I cannot reach it. And now there has to be a inner circle also. And I wrote a formula for that, right? Um, yep. When I was taking in the input, let's say this maximum distance is yes, consists of steps, right? And some steps will be smaller and some will be larger. And let's say this one step M, let's call it M. This is the maximum length step that I can take. So my inner circle, this inner circle would be something like this. Let's say I take M, I go M forward, and then I am doing these other smaller operations and going back in the direction that I came from. And let's say this point is the maximum that I can reach, which means that M is the maximum distance that I can cover in a single step, and this is the sum of the rest of the steps, and going M in one direction and then coming back. This is how close I can get to the starting point, and therefore this would be the inner radius, because no way I can reach any point inside this circle. So my answer would be, wait, let me erase the green one. Erase the green ones. So my answer would be this. If the endpoint is anywhere here, then we are cool. If it is here, then no. And if it is inside this, then no. And that is what I did. How to be good at DSA practice. Hemant Ragul P. Code Forces rating. It has increased now. It is now 1900 something. Yeah, 1000, not 900, 1093. And to get good at DSA, you have to study and practice. Yeah, you can do this drivers sheet. This is what I am doing. Wait, shit. This is what I am doing. Yep, can practice from here. Like study the theory from there. This was the B1, and this is my solution for that. I have this. Yeah, first I'm taking in the inputs all like n, then the starting point and then the ending point. Original distance would be this thing squared. Square is the no, multiplied by 2. I think instead of no, that is good. Square of the distance in x1 minus x2 square plus y1 minus y2 square root. That would be the original distance. And t, what is t? T is the total distance, and mx is the maximum distance that I can cover in a single step. And when I'm taking in input, I am adding every input to t, and I'm taking the maximum, and I have a boolean done. So if maximum is less than t minus maximum, then original done equals original distance. Wait, what does this mean? This means that, wait, if maximum is less than or equal to t minus maximum. Yeah, cool. So in this case, we have which color? Yes, this is our maximum, and this brown part, is our total minus maximum, and we are checking if this brown part, which I'm representing by green, if this thing is smaller, if this thing is larger than maximum, that is, if this brown part is larger than the pink part, and if that is true, that would mean this radius is 0, and I can reach back the starting point. So yeah, and so I know the inner radius, and I just have to compare the end point with the outer radius, and this is what I do. So if original distance is less than or equal to t, that is, if the distance that I have to move to reach the end point, if that is lower than or equal to this total distance that I can go, and if that is true, then it is true. And else, if that is not the case, then I know that there is some inner radius and there is some outer radius, and I have to compare the original distance with both. So this condition has to be true. First of all, original distance has to be lower than the outer radius, and original distance has to be greater than this. And what is this thing? This is maximum minus this brown thing, and this would result in this radius, and I hope that makes sense. This radius, it would result in this radius, and this radius I'm checking my original distance can be equal to or greater than this, so somewhere here, and if it is, then true, and if done, then yes, otherwise no. So that is my solution, and I got it right in second attempt. Why was it wrong in the first time? It was wrong. Wait, oh, what was the mistake in my code? Yeah, I was not considering the inner circle. Yeah, I was only comparing with the outer circle and not considering the inner circle. That was the problem. And now we can move on to the third question. And third question I was unable to do during the competition, and I did later after the competition. A good problem. Let's see what it is. Yeah, I remember this one now. Mhm. You are given four positive integers n, l, r, and k. This one was pretty cool, this question. You need to find the lexicographically smallest array A of length n consisting of integers such that you have to return an array of length n, and these two conditions have to be true. So for every I, L has to be, yeah. So every element in that array has to be greater than or equal to L or smaller than or equal to R, every element. And second condition, the AND of the whole array, if you take the bitwise AND of all the elements in the array, that has to be equal to the bitwise XOR of all the elements in the array. That is cool. So if no such array exists in which this condition is not possible, then output -1. Otherwise, if such a array is possible, then output the kth element of that array. And here is the input, just n, then L, R, and K. So yeah, it would depend on n. If n is odd, right? XOR returns in XOR. Oh, yeah, yeah, cool. So the thing is this: if n is odd, then the solution is very easy. You can just take L, and yeah, one more thing. This array has to be lexicographically smallest, which means put small numbers first, small, and only increase a number when it is absolutely necessary to. And if n is odd, then the solution is pretty easy. I have L, I have R, and I have to return the kth element. And if n is odd, what you can do is, let's say n is 5, and if n is odd, 5 is odd, I can just, let's say in this case, L is equal to 3, R is equal to 5, and K equals 4. So smallest element I can take is 3, and the largest I can take is 5. But n is odd, so I will, okay, instead of just telling the solution and then explaining why that is correct, let me try to deductively solve this thing. Given these things, I, okay, so first condition is easy to fulfill. I just have to choose elements between 3 and 5. And the second condition, I am taking AND of all the elements, and that AND has to be equal to the XOR of all the elements. And what does that mean? It will mean that XOR, when I'm taking XOR of a number with itself, so let's say not x is, x would represent XOR. Let's say I'm taking a XOR a, it would result in 0. And if I take XOR of 0 with any number, it would result in that number itself. And if I'm taking AND of some number, let's call it a, and a, it would result in a. Fill the array with a single number, like let's say 3, 3, 3, 3, then the XOR of these two would be 0, and then 0 XOR with 3 would be 3, then 3 XOR with 3 would be 0, and then 0 XOR with 3 would be 3. So the XOR of the whole thing would be 3. And if I were to take AND of these two, it would result in 3, and of this 3 with this 3, it would result in 3, and of this 3 with this 3, it would result in 3, and of this and this would be 3. And here we have XOR and equal to XOR. So that is cool. If I fill the array with one number n times, then it is cool. That is the answer. And then just return Doesn't matter what the value of k is, I can return that number because that number is the one that is present everywhere. And now, and I have to make this lexicographically the smallest. So the smallest number that I have is 3. So just fill the array with the smallest number when n is odd. And when n is odd, so the solution is very simple. Yeah, I take n, and if n is odd, just return L. That is the whole solution. If n is odd, then just return L, because no matter what the value of k is, L is the only number in my array. My array is just filled with n, with L. But if n remainder 2 equals 0, that it is even, then taking XOR of some element even number of times would result in 0, but taking AND of some element even number of times would result in the element itself. Let's call it A. But I have to make these two equal. How do I make them equal? To make them equal, I either convert this 0 into some number or this number into 0. And I went for converting this into 0. So I will have I have like even number of places in my array, right? And to make some number 0 by taking AND of that number, let's say I have a number 5 and 5 equals 0 1 0 1. In binary, 5 is equal to 0 1 0. And I have to find the next number where this bit is 1 and all of these are 0, and that number would be 8. So 8 is 1 0 0, which means I have to find a number that is a power of 2, not a power, yep, we can call it a power, which is a power of 2 but greater than this given number, which would be 8. And for 9 it would be 16, and for 17 it would be 32, and then it would be 64 and 128, and just like that. I think I'm not doing a very great job at explaining this, but yeah, let me try. So to make both the and to make both the XOR and the AND equal to 0, for XOR I do not have to do anything, because for XOR there is only one. Whatever numbers appear, they have to be in pairs. If I'm choosing one number, then it needs to have a one pair of its one other number which is equal to it. Yeah, it has to have a pair of itself there. And for AND, if I have just 1 0 at any place, then we are cool. So let's say our limit is from 5 to 10, and we have to fill these. So to make 5 equal to 0 by taking AND of itself, if of 5 with some number, I have to take AND of 5 with 8. And is 8 within the limit? Yep, 8 is between 5 and 10. So I know for now one thing, that I will have 8 in my array, and to fulfill the XOR condition, I know that I will have to have additional 8, because every number has to be in pair to make the XOR equal to 0. And then I have to have 5 also, because I have to have any other number whose by taking and of that number with 8 I would get 0, and the smallest number is 5. So let me fill up this array with 5 any number of times, like 5, and the last two would be 8, because I need to have at least one 8, and if I'm having one number then I have to have a pair to fulfill the XOR condition, and just taking the AND of these two would make it equal to 0, and if that is 0, no matter what the other numbers are, the thing will become 0. And that is what I did here. And the thing that seems to me pretty cool is this way of finding the next biggest power of 2, the next smallest power of 2. Here I'm taking log 2 of L and converting it into an integer and then adding 1 to it. And what this will do is whatever L is, that is the lowest number, it will return some number which I can take to the power of 2, let's say call it x, and x would have an integer part and then a decimal part. And when I convert this into a integer, this decimal part will be lost. I will only have this integer part, and that raising 2 to the power of that integer part would give me something that is lower than L, but I need to go one step above than L. So for that I just add 1 to it. That's cool. And next is that number, and I can just shift 1 left n number of times to get this power of 2. That is the greatest. So in case of 5, if I do log with 2 5, it will result in 2 point some number, right? And when I convert this into an integer, I will only get 2, and then when I add 1 to it, it will become equal to 3. So next next equals 3, and when I do this, 1 left shifted by 3 places, I would get 3. One goes to the left once, twice, and thrice, and this number is 8. So that is cool. And then I am seeing, so I know that the last two numbers would be equal to this thing, this one shifted by next amount left. So if k is less than n minus 2, then I just return last number, otherwise I return this power of 2. But here I am also checking that this next has to be this power of 2 that I am getting has to be less than or equal to the right limit, and at the same time, since I need at least two pair of numbers, n has to be at least equal to 4, right? Yup, that is good. And I did this in like, it took me a like couple of tries, but I got it right. That's cool. Yeah, we can move on to the next competition, I guess. Contest, not a competition, contest. This one. And one special thing about this contest is that, let me show you. Mr. Tourist from Belarus was here, and he did the first problem in 1 minute, the second problem in 6 minutes, the third in 8, not in 8, but combinedly 8. So he did the first problem in 1 minute, and after that, he did the second problem in 5 minutes, that is 6 minus 1. And he did the third problem in 8 minus 6 minutes. That is this one he did in just 2 minutes, and this one he did in 5 minutes. So that is like pretty cool. But he did the first one in 1 minute, and for me, I did it in 11 minutes. That is like 10 minutes time difference. And a friend of mine also gave the competition. That is cool. And in this competition, I was just able to get two questions correct. And let's review the questions. The problems. Deranged deletions. Dearranged deletions. So call an array B of length M a derangement if the following properties hold. So let C be an array of length M such that this that is, and then sort C in descending order, and B is not equal to C for any number. So uh, an array is called deranged, dearranged, let's call it deranged, not so. I have an array B and I want to call it deranged or not. I want to figure out if it is deranged or not. So I create another array C, and which is exactly equal to B, and then I sort C in non-descending order. That is ascending order. It is either decrease, it is not decreasing, it is just ascending order. And if none of the elements at same indexes do not match in B and C, then it is called dearranged. And given an array, what do I have to output? I think I have to output, yeah, yes, no, yes, no, yep. Output whether it is possible to perform some possibly none operations such that the remaining elements from a derangement form a derangement. It is possible, uh, if it is possible, output any possible remaining array. The remaining array must be non-empty. Okay, and shit, I am just thinking that I could have done this in a more easier method, I think. Right. My method was to literally create a C array, then sort it in ascending order, and then match every element in C. Let me open Excalibur to create. Here is my original B array with some elements, right? Yep. And then like literally copy that and create another one called C, and this C will be sorted in ascending order. That is, the values are increasing, and then I match these corresponding elements. These same elements, and if at any point they are equal, then I just have to remove them, and if they are not equal, that is an element is not equal, then I think I can just output that. I can output that element and call it my array. I cannot output just that element. I will output all the elements starting from the first one that was not removed and go further and further and printing all the elements that were not removed. And how do I know one element is removed or not? I know it by comparing these two, my original B array and the C array, the sorted one. If at any point they are not they are equal, then I just remove that element from B and just output these elements, these which were not equal. That would be my answer, and that is what I have done. 1036 deranged deletion. So first I take in n, and then I create two arrays, vector arrays, vector integer arrays of size n, and I take in the input in A and also into B, and then I sort B, and then I keep a counter of the ones that I of the number of ones that I have removed. Keep a counter of the number of elements that I have removed, and then I traverse through the array, and then I'm checking inside the array whether select, yeah, whether any element is matching or not, and if they are matching, then I can remove it by making it equal to, let's say, -1. If an element is -1, then let's say it is removed, and I am increasing remove by 1. And at the end, if I see that this is not possible, if I see that I have removed all the elements, then no, not possible. But if I have not removed all the elements, I output yes, and then I output the number of remaining elements, which is n minus the number of elements that were removed, and then in the next line I'm traversing through the array, and if an element is not equal to -1, I output it, and at the end a new line. That is it for this one. And then the second one, this was the last question that I was able to do in this contest. This problem differs from G. I didn't even read G. You are given an array A of length n with elements satisfying this. So n is the length of the array, and every element in A is from 0 to n inclusive. You can perform the following operations at most once. At most once. Choose two indices I and j such that I is smaller than j, and set I equals to AI equals to AI plus AJ. Then set AJ equal to 0, and then output the minimum possible value of min AI plus min AI plus A1, minimum of first and second element, and then so on till minimum of all the elements you can get. And that is cool. And n is at least 2. This, and then I have to output the minimum. So this was also pretty cool. In this, I have been given an array of numbers. Right. It has some numbers, and yeah, it has some numbers, a lot of numbers, n numbers to be total and exact. And I have one operation which I can perform. I can choose two indices, two numbers, let's say this and this, and then I can make the first one equal, let's call this A and call this B, and I can make the first one equal to A plus B, and the second one becomes equal to 0. And then I have to find the minimum value of this expression after either performing or not performing the operation. So if there are two options, first of all, either I perform the operation or I don't perform the operation. That, and yeah, let's say if I perform the operation, what would be the best thing that I can do performing the operation? So I know that the second element is going to become equal to 0. So I want this 0 to appear as early in the array as possible. And that would be the second element. Since the first element has to be before the 0, therefore let's call the first element at index 0. Let's say it is the ith index in this case, and the second one is the jth element. And what I will do is, if I'm going to perform the operation, the first one becomes equal to the its value plus this value, and this one becomes equal to 0. So if this is the case, then when I'm calculating this expression, the value of this thing, minimum of a1, becomes equal to a1 plus a2. And from then on, when a2 is included, a2 will be the minimum because a2 is 0. So in every other expression, the minimum would be 0 and I won't be adding anything. So either I perform the operation or I not, or I don't. And if I'm going to perform the operation, I will perform it here on the first and the second elements. So if I perform the operation, then the answer would be a plus b. And supposing a is the value of the first element and b is the value of the second element, the answer would be this. But if I do not perform the operation, the answer would be this thing plus the minimum of this plus the minimum of this, these three, then the minimum of the first four elements, then the minimum of the first five elements, and so on. And that would be pretty big. So the only condition that I would not perform the operation would be when a plus b is greater than whatever this huge sum is going to be. And this would be the case, let's say, if a is smaller, right? If a, let's say I have a and I have b. A, if a is greater than b, then in the first case I am going to add a. If I do not perform the operation, then this thing I would have to add a, this would result in a, and then the minimum of these two would be b, so I would add b, and then I would move on to add, let's say, c, d, and c, whichever the minimum element is. But I know at least I'm adding these two when a is greater than b, or maybe even equal to, then I'm adding at least these two. So in this case, this whole sum cannot be greater than a plus b, because I am at least adding a and b and then sum. So when a is greater than equal to b, I should perform the operation and a would become equal to a plus b, and then taking minimum of any elements which include the second, taking the minimum of any set of elements which include the second element, minimum would be 0. So plus 0 plus 0 n times, and this would be our answer. So it would be good to do the perform the operation when a is greater than equal to b, right? And in that case, the answer would be a plus b. But in the second case, when a is less than b, right? If a is less than b, let's say I have elements. This is a, this is b, and then I have some elements. So the minimum of this would be just a, then plus the minimum of this would be a, and then we'll go on and find the minimum. But if and that would be if I do not perform the operation. But if I do perform the operation, I would get A plus B plus dot 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 dot, dot, plus 0. This would be the answer. And if I do perform the operation, then this would be the answer. If I do perform the operation, then this would be the answer. And if I do not perform the operation, then I would have at least A plus B plus the minimum of like the subsequent expressions. So I have to compare A, and in this case, this would only be preferable, that is, performing the operation would only be preferable when this thing is lower than 2A plus the answer of the subsequent expressions. And that I think I have to manually calculate and compare it with this and find this out in case A is lower than B. I think that is what I do in the C. Take in A, yep, yep, yep. Take in the number of elements, then create a vector of 64-bit integers because A is big. Because no reason, I just do that. Yeah. This and make the array, then x equals 1. I think x is the answer. What the heck? I'm on the wrong. Ah, shit, this is B. My bad, my bad. B. First, take in the number, then create a vector A of size n, then take in the inputs and then see. First, here I am checking A0 and A1, and I can just index this because I know that n is at least 2. So this is cool. This will not result in any error. And if that is true, then the answer would be if A is less than B, mhm, should did this thing work? Got accepted in first try. If A is less than B, shit. Why did I do that? Yes, 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 yes. Fuck, yes, shit. Yes, 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 yes. Now I remember. So, in this case, when A is lower than B, then I know that the minimum of these two would be A, and the minimum of these two also would be A. And let's say I will do the operation in this case also, and no matter what this third element is, I will take that and perform the operation on these two. So this B would become B equals B plus C, B equals B plus C, and C would become equal to 0. So the minimum of these two, the the minimum of this would be A, the minimum of these two would be A, even though its height has increased, and this is like 0, this is 0, this is nothing. And then the minimum would always be 0. So at least I am getting A plus A, that is the minimum sum that I can get, and that is what I return 2 into A plus. Yeah, realizing that this was pretty cool when I realized that I can perform the operation on any two numbers. So that was the key there in that case, and I did this. Then moving on to the third question, it was like very stupid when I was unable to do this, right? And I didn't even had any ideas how to do this. I had ideas, but I didn't know how to implement them in a effective manner. And then I looked up what tourist wrote for his solution, and it was pretty cool. Um, Standings. Wait, but first I have to explain the question. That is important, kind of. That is the whole point of this stream. This is stream. It has only been 1 hour. That is cool. Maybe I will even solve some questions. Alice has an array A, okay, consisting of n positive integers. The array satisfies the beautiful property that AI divides AI plus 1, that every element divides the next element. And Bob sees Alice's beautiful array and is jealous. To sabotage her, Bob first creates an array B of size A, which is equal to A, of size n, which is equal to A, and then he chooses some numbers and multiplies them. Then he chooses some numbers and multiplies them with an integer x. And then I am given that array B. So to explain the question here, and there is an original array A. It has some elements, right? Quite a few elements. And then there is Bob, who creates a copy of this array. He creates a copy of this array, calls it B, and then from this, and then he also chooses some integer x, and he chooses some elements of this array and multiplies them by x. Multiply them by x, and I am given this array, and my task is to figure out what this x number is. And in this A array, I know that every element divides the next element. That is B divided by A is some integer. That is remainder is 0. If this is A, this is B, and this holds for every element. B divides C divides D, A B C D E F G H. So that is cool, and because of this, some things are not adding up. Now the thing is to first figure out which of these pairs are not following the property and then move from there. So if I see that I have a number and it does divide the next number, if I have a number and it does divide the next number, then we are cool, I can move on. And if I see I have a number which does not divide the next number, then I know that something has been multiplied to this number, which is making it not dividing the next number. And my my task is to figure out what the original number was and what must have been added, multiplied. So to find out the original number, or at least an approximation to the original number, let's call this A and let's call this B. I will have to take G, C, D of A and B. It would be the greatest common divisor of A and B, and then I have to see what the extra part is in A, which is making it not divide B, and that would be A divided by this GCD. That would be the extra part in this. So let's call this x0, and then I will see that here also the numbers are not dividing, and I will find the extra part in that. I will call it x1, and here also I will see that they are not dividing. I will find the extra part and call this x2. Now the answer has to do something with these extra parts which are there in these numbers which are not dividing their next number. And to find that, I have to take the HCF of these. HCF of x0, x1, or like xi for every extra part. This. It is very fun to type with the mouse. Extra part of these. And why HCF? Because I know that this thing I can factorize in prime factors. This thing I can factorize in prime factors. This thing I can factorize in prime factors. And I do not want to repeat. I do not want factors to repeat. And I only want their frequency to be equal to the maximum time that they are appearing in any of these extra factors, and that is just equal to their HCF. And that is what I have done. After, of course, copying the answer from Tourist, Mr. Tourist. Standings. Contests. Gennady Korotkovich. He solved 8 questions, and you can just go and look up his solutions. And yep, click on this. And for C, his solution. Mm, Submission, yep, submission for this. It is coming up, loading. Shit, he got all of these correct in first try, and only this error, TLE error, and one. Doesn't see. I see it. So this is his code, and these are the macros that he uses. There's also this. I think he submits using the submit button, which is around here. Hmm. Yeah, he does not call any external function called solve, because that I think adds an overhead. Not I think, it does add an overhead to every test case, and that is bad. So I have also changed my remap to remove the solve function and solve it like this, which is yeah, this is going to be my default thing in which I code. So there is no longer any call to a external solve function, and I will write all the code in here. And shit, go back. Good problem. No, yeah, yeah, this is the one. So first I'm going through the array, and I'm going through all the adjacent pairs and take GCD of all of them, and x is equal to LCM of the current number divided by the GCD, and x, LCM of x and the current number divided by the GCD. That is the answer. So just 2 lines of code. This is what he wrote. Yep, that is cool. And the that would be analysis of the questions that I was able to do. And Ecto is going to stream in 5 hours, in addition to CF solving. That is cool. And my rank is also not nice, but I would like to go up to pupil. And the next contest is, I guess, 19 or something. Yeah, on 19th calendar. Today is 8th, and the next contest is on 19th for Division 1 and Division 2. This one. And I will register and give this competition. Contest, not a competition. Yeah, that would be it for today's stream, or maybe let me play a little bit of chess. Nope. Yeah, this would be it for today's stream. Yeah, thank you for being here. Stream for only 1 hour and 10 minutes. And this would be it for today's stream. Thank